Hello, everyone. I miss you so much, and I really hope and pray that everybody is healthy and staying safe. So to start off, this is section 3.2. We finished up with 3.1, where we were just solving systems of equations, either with a table, with a graph, or algebraically by substitution or elimination. So this lesson is actually solving systems of inequalities, which we do by graphing. So hopefully you remember that inequalities, whenever you have inequalities, that means that there will be some type of shading involved. Okay, so to solve a system, remember a system is two or more equations, or in this case, inequalities. Oh, that's hilarious. Let's go with this. Two or more equations in two or more variables. Okay, we have actually not equations, but inequalities. So when you solve them, you're going to, step one, graph each inequality and shade the correct area. Remember that our line will either be dotted or solid. Then you're going to identify the region that is shaded for all inequalities, and that is the solution of your system. Okay, so one of the things, I worked this out because I think y'all all know this, and I just wanted to be really quick, but I wanted you to be able to look at how I expect your work to be shown when you do this for me. Okay, so first off, you have two lines here, all that we're graphing. We're going to have some lines, but we're also going to have the absolute value function. I would like to see you identify a point and the slope from each equation. So that's what I've done. This is your pink line. This is your orange line right here. Okay, notice the pink one is solid because that says less than or equal to. The orange one is dotted because that's a greater than. And I just draw arrows on it, and then I shade that region that is overlapping. Okay, to refresh your memory about the absolute value, okay, y equals absolute value of x. The vertex is always at 0, 0, and the slope is the coefficient of x plus or minus 1 in this case. So again, solid and dotted and shading the overlapping regions. Okay, sometimes when you graph two equations, two inequalities, they actually have no overlap. Okay, so in this case, and I didn't write it on that one, but I will. Okay, so this first one, 2a, if you can see, the lines have the same slope, but they have different y-intercepts. And for that reason, and we shade, there is no overlapping region, so it is no solution. On 2b, so you still, even though they don't overlap, y'all, you're still supposed to solve it by graphing. So this is the work that supports your answer that there's no solution. So over here, again, notice that my graph is by 4s to get my y-intercept of negative 24, x-intercept of 12, okay? Still have a positive slope of 1 here. That is my absolute value graph. But these two shaded regions never overlap. So again, I should have written down here that the answer, oh, that was pretty bad. The answer is no solution to this one as well. Okay. All right. The last thing that you have, again, just bringing it all together and preparing you for the next lesson that we're going to cover. And that is putting 3 or more inequalities on the same graph. And in this case, you're going to find the coordinates of the vertices of the triangle formed by each system. Okay, these two are both triangles. Sometimes they're not triangles. You're just looking for that region. Like I said, we'll talk about it more tomorrow. But again, or in the next lesson. Again, I graphed all of our inequalities and I color coded so you could see. I wrote down a point and a slope for each of those. You figure out which is the easiest way to graph it. When you are graphing, y'all, I do expect to see some shaded region, which is the overlap of all 3 of your lines. Then A and B, the points look pretty obviously, and I mentally check them. Okay, this is the intersection between the orange and the purple, which is these 2 lines. So you can put the point 8, negative 4, 8 in for x, negative 4y, check it for that one, and check it for that one. So then you know that's the point of intersection. Same thing with negative 3, 3. Okay, but this point down here was not so pretty. And so for that reason, I actually had to go solve it algebraically, which is what you just did in the last lesson. I chose elimination. So which one? This one. We're looking for the intersection of pink and orange, which is the first two. And so I multiplied that top one by -2 so that when I add them, the y variable would fall out. Solved for x and then plugged it into the pink line to find the corresponding y value. Okay. And again, you can check it. But this is the kind of work I should see if ever the points of intersection are not a nice integer. Okay. Same thing for this one. So hopefully that all makes sense to you and demonstrates to you what kind of work should be on your homework and what kind of work you'll have to submit when you do your quiz for me. Hope y'all are having a great day. Email me if you have any questions or email me if you have any questions. Thank you so much. Bye.